Hey everyone, and welcome to another episode of Motion in Motion. In today's episode, I'm going to show you some of the basics of Objective-C and how it translates to RubyMotion code. This is especially important for people first starting out with RubyMotion, because though there is fantastic learning resources out there for RubyMotion, by understanding Objective-C at least a little, you always have access to all of the existing and upcoming Objective-C learning resources. To show you the translation between Objective-C and RubyMotion, I've got an Objective-C project open in Xcode and a RubyMotion project open here in my terminal. Jumping straight into it, let's look at something basic like creating a class. A common class to create in a RubyMotion application is a UI View Controller subclass. So let's create one of those called Master View Controller. This is simple in RubyMotion. I'll just create a new file called masterviewcontroller.rb, and I'll create my class using Ruby's way of doing so. Jumping into Xcode, I'll begin to do the same. Because Xcode is an IDE, there is some class generation wizard we can use, which isn't the topic of today, so I'm going to fast forward past it so we can look at the code once I've removed the extra stuff the generator adds. In Objective-C, it's commonplace to use two files to define a class. A header file where the public interface is defined so that it can be imported into files that use a class, and the implementation file which contains the implementation of all of our methods. I'll show you the header file first. You can see some comments Xcode has added to the file for us at the top. But then the first line of code is talking about importing UIKit. This line is just saying to Xcode, this file is going to use some stuff from UIKit. There is no need for us to do anything like this in RubyMotion. Instead, we specify the frameworks we use in our rake file, which defaults to UIKit, Foundation, and Core Graphics for an iOS application. Next is something that looks almost like our class definition in our RubyMotion application, and you would be quite right in thinking that. This is the start of what defines what properties and methods will be in our class, as well as what superclass we're using. The @interface at the beginning of the line is the start of this interface definition, and is followed by the name of the class, a colon, and then the class we're inheriting from. I close the interface definition with the @end. The implementation file is sort of similar to the header file. It starts out by importing the header file so that Xcode is aware of the interface I'm implementing. Then we have the implementation definition, which is where I'll start putting all of my method implementations soon. It's very similar to the interface definition, except without the superclass. The import in this file is importing just the one file, similar to how we might require something in normal Ruby. This isn't needed in RubyMotion. Instead, RubyMotion will compile all of the source code in our app directory, plus and minus what we tell it to. The next thing we might need is a property, the definition of which is very different in Objective-C and RubyMotion. In RubyMotion and other Ruby implementations, we have attr_accessor to create a property. This is quite a bit more verbose in Objective-C, mainly due to the type and reference details that need to be defined with it. In Objective-C, a property is defined in the header file and starts with the @property declaration, followed by the reference type and atomicity, which is usually non-atomic. The reference type I'm using here is strong. This is so that when there is a reference to this user, it adds 1 to the reference count, ensuring that the user isn't deallocated from memory while we still want it around. The other option for our reference type is weak, which would mean that we don't mind if it gets deallocated. This is usually used to stop reference cycles where two objects reference each other and so can never be deallocated. Next in the property definition is the type. Remember that Objective-C, unlike RubyMotion, is a strongly typed language, so we have to tell Xcode what types are being used and returned and such. Here I'm simply saying that the user is going to be a pointer to an NS string. The way you know it's a pointer is because of the little asterisk. In RubyMotion we work with pointers very little because it's usually handled for us unless we're doing something a little more tricky. And last we have the name of the property, user. Properties in Objective-C can be called and accessed just like we use them in Ruby, using dot notation, as opposed to the method calling syntax I'll show you in a bit. Something else we need to be able to do is define a simple method. I'm going to create an instance method in the RubyMotion version called refresh that takes no parameters. To do this in Objective-C, we need to define the interface of this method separately from the implementation, so we start in the header file. Inside the interface, I'll start with a minus sign. This specifies that it's an instance method and not a class method, which would be a plus sign. I then need to specify the return type, which in this case, because we return nothing, I'll say that by using the void keyword. Lastly, for this simple method, the only other bit we need is the method name, which is refresh. Now to actually make the method do something. In the RubyMotion app, I'm just going to use the puts to print out the user string. To do this in our Objective-C application, I'm going to copy and paste the method from the header file, open up the implementation file, and paste it inside the implementation, replacing the semicolon with curly braces. Now inside of those curly braces is where I can write all my Objective-C code, which in this case I'll use nslog, which is similar to puts in Ruby, to print out the user string. The two parameters that nslog takes is to do with string formatting, which I'll talk about another time. With the basics of defining methods out of the way, let's take one small step and look at how to take a single parameter. In our RubyMotion app, we simply accept the parameter in some parentheses, but there's slightly more to it in Objective-C of course, mainly due to it being a strongly typed language. I'll start in the header file to declare the public interface of the method, but this time I separate the method name from the parameter using a colon, and between the colon and the parameter name, inside of parentheses is the type, which in this case is a pointer to an NS string. The steps for implementation are the same as with no parameters. Simply copy and paste the interface definition into the implementation. Swap the semicolon for curly braces, then inside of the method implementation we can use that parameter. Now for another small step, multiple parameters. You may have seen multiple parameters in RubyMotion before. They look similar to named parameters in normal Ruby. The main difference is that the named parts actually make up the method signature, so you can actually do method overloading in RubyMotion, unlike other Ruby implementations. For example, if I change the changeUser method, which uses snake case for the naming, to be changeUser using camel case, like the changeUserAdminStatus method I have here, they would both be totally different methods, unlike other Rubies. Continuing on to the Objective-C code though, I'll once again start in the header file. I'll create the interface definition for the new method, which separates the parts of the method by a space instead of by a comma. The full name for this method is changeUser::adminStatus:. Now that can once again be copy and pasted into the implementation to be implemented. That's basically all you need to know about classes for now. So let's take some steps back and look at some type literals for strings, numbers, arrays, and dictionaries, which is the name for a hash in Objective-C. It used to be that you would actually allocate and initialize each of these, but now more recent versions of Xcode and Objective-C provide type literals for these. Each of them starts with an @ symbol, and then they use basically the same syntax as they do in Ruby. For strings, you use the @ symbol, then use quotes to wrap around the text. Numbers use the @ symbol, then the number. Arrays again use the same as Ruby, but with an @ symbol. The only difference is a dictionary, which remember is called a hash in Ruby. Instead of using the shuttle between your keys and values, ignoring the case in Ruby where you're using a symbol, you just use a colon. The next thing I want to show you is how to actually call methods and initialize objects in Objective-C. But before I do that, I'm going to quickly generate an app delegate for us to view this kind of code. Alright, with that generated, let's take a look at some of this code. Like I said before, for properties we can still use the dot notation, but when it comes to calling methods, even those used for allocating and initializing an object, we wrap the call to a method in square brackets. Inside of the square brackets is a pairing of a class or object, and a method to be called on it, similar to a kind of Lisp style. This pair is separated by a space. You can of course nest these, calling methods on the result of previous pairs of these method calls, like you see here. You can even use a property as the first part of the pair. Initialization in Objective-C is done in 2 stages, unlike Ruby where we just call new on the class. The first step is to call alloc on the class. This will allocate the amount of memory needed for an instance of this class to exist. Then on the result of that, we call one of the potentially many specialized initializers, or simply init in some cases. Here you can see a specialized initializer called initWithFrame is being used, which is then getting passed the value returned from calling the bounds method on the main screen. It's quite common to use one of these multitudes of initializers when working with Objective-C framework classes like UIKit in RubyMotion, instead of just calling new. Here are a few other things to note in this file and about Objective-C. To start with, you can see an example here of a method that does not use the void return type, and instead is returning a bool. With booleans getting brought up here, I'd like to mention the odd thing about them in Objective-C, which is that instead of using true and false as the 2 options, Objective-C instead uses yes and no in capitals. Luckily, RubyMotion still uses true and false. Something which I haven't mentioned yet is to remember that Objective-C does use semicolons to denote the end of a statement. So that is it for my basic introduction to Objective-C. There is of course more to learn than just that, but this should give you enough to get started with looking at Objective-C tutorials that you find on Google, and be able to implement the code in RubyMotion instead of Objective-C. You now have a whole world of new code to look at and start learning from. I hope you enjoyed this episode, and I can't wait to see you in the next episode of Motion in Motion.